Hello, everyone. This is Bryan Smith, and welcome again to 321 Gang's technical podcast, Change the Conversation. And we are thrilled again to have our friend Amit Talwar from IBM joining us. Amit is part of IBM's Internet of Things and Watson group. Welcome, Amit.
Thanks, Brian. Thanks for having me back.
Absolutely. Also known as the indestructible sword. Got to throw that in there. I think that's super cool. Anyway, this is the third of a series of podcasts that we are doing to discuss Automotive SPICE, also known as ASPICE. And just to recap very briefly, episode 1 was pretty high level, as you might imagine, talked about why companies do this, why it's important, the fact that OEMs in this space are demanding that their suppliers have a certain ASPICE level, ranking, what do you call that, a level, a ranking?
Capability level, rating, capability level, yeah.
Capability level. And what are those levels, by the way? Does it go to 1 to 10? Is it
1 through 5?
1 through 5. So similar to the CMMI stuff back in the day, yeah. Okay, so 1 through 5, and in order to assess those capabilities, there are formal assessments, and sometimes there are internal assessments that they go through. Sometimes the OEMs want an external assessor. So it's pretty serious because a lot of these contracts are, multiple millions of dollars, and you sure don't want to miss out because you're not able to meet with those levels.
Yeah. So
let's see. So I'm going to cheat here. So episode 1. Again, high level. Episode 2, we really focused on the establishment of bidirectional traceability and ensuring consistency, and the fact that tools are a key component to that capability, because if you don't automate it, then you're looking at spreadsheets and you're looking at a lot of time sunk and looking at missing things, because if something changes on one end, let's say the requirements bit, and you don't change the architecture to reflect that, or vice versa, there can be big problems. Okay. Which sort of brings us straight into episode 3 here, which we are calling Allocating Requirements to Architecture. And because it sounds like requirements, as we mentioned in the last podcast, are really the core of this, maybe the hub of this wheel, because it all starts with the requirements and then changes to those things, to either the requirements themselves or the things that relate to those requirements as you move through the development and engineering process. If you can't manage those changes effectively, then you get yourself into a lot of trouble. So why don't you fill in some of the blanks there, Amit, for me, because I'm sure there are many.
Yeah. So in this session, we really kind of focus on the areas of where I see organizations or the tier 1, tier 2 suppliers struggle with being able to define their requirements and allocate them to system architecture. If you look at the systems engineering process model in ASPICE, looking at the architectural design process requirements is one, you have to allocate those system requirements and reflect them into your system design. But then you also need to define what the interfaces are for those system elements. And it's very important to describe that dynamic behavior of your systems. So you want to understand what are the interactions between your different system elements and design that how the system is going to behave.
So we're moving into modeling. That's the modeling aspect there, and we're talking about model-based systems engineering and the lexicon around that world.
Exactly, right? Exactly. And part of this is being able to establish that bidirectional traceability between the requirements and the models that are describing the behavior of your system.
Right.
And we have to, getting back to our last conversation, it's not just about defining the model and creating it and understanding what the behavior of that system is going to be, but we have to establish that bidirectional traceability back to requirements. And so what we're going to show today is how we can establish that bidirectional traceability to a model, which we say in this example we have a new requirement and we're going to make a change to the model. We're going to establish that bidirectional traceability, and we're going to see that if something does change on one end or the other, we'll see that notification.
Mm-hmm.
And,
And I
and these
suppose you
are,
can also look at this. I mean, sorry to interrupt, but let's say I'm in charge of this project, or I'm one of the engineers, and I want to consider a change to something. So I can change an element here, and I should be able to then trace that back to what requirements. I mean, let's do it that direction. For example, I make this change, or I potentially want to change this element in a model, and then I can trace that back to what requirements would be effective, and maybe decide not to do it. Is that
exactly,
a use case that
that is
this can
definitely a
be?
use case, yeah.
Okay, that's cool. And then I assume there are tons of different kinds of models. What are the models types that you typically use, or that you're going to be
Yeah,
showing?
so when you talk about describing the dynamic behavior, you're going to see things like utilizing sequence diagrams or
Okay,
activity diagrams.
all right.
To be able to understand the behavior, you're looking at different state charts that could be utilized. Basic SysML, UML block diagrams to
Mm-hmm.
describe the interactions of the different functions of your system or features of your
All right.
system.
Okay.
So those are some
So
of the things that we're going to show today.
excellent. So I have one other thought I want to throw out there. We talked in our last two podcasts about the fact that we have these OEMs sitting at the top, and they're pushing these ASPICE requirements down to their suppliers. How is there? And I'm sure we're not going to see this today, but are there use cases out there that exist that take the things we're talking about, bidirectional traceability between these tools, and today specifically between requirements and models, between OEMs and their suppliers, so that there's communication and collaboration through that supply chain?
Yeah, there's ways that can happen today. That's definitely a use case that OEMs want to be able to
Mm-hmm.
utilize with their suppliers. So the ability to
That's
say, if I'm an OEM and I'm getting a portion of my system developed by a supplier, I want to understand that, one, do they have their traceability from their standpoint, but how does that relate to when I take that supplier's system and I have to integrate it with another supplier's system,
right.
and how does that relate back to my high level system requirements for my overall product?
Sure,
And there's
sure.
ways that we can establish that.
I mean, that I know that adds, exponential complexity to the overall process, but to be able
Yeah,
to automate it and see those links and communicate effectively
yeah,
seems like would be very helpful.
yeah, exactly.
Well, great. So I know you've got something prepped for us in the IBM Collaborative Lifecycle Management Tools. So let's go ahead and jump into that.
Perfect. Sounds good.
So I guess we're going to start with a few slides. Amit, what are we looking at here?
Yeah, so this is straight from the ASPICE process model. Looking at that system.3, base practice 2, 3, and 4, and this is kind of what we're going to cover. If you look at those design process requirements, one is allocating those system requirements, making sure that those system requirements are actually allocated to the architectural design, and that we define those interfaces, and that we describe that dynamic behavior. And if you look at the process outcomes, this is just clipped straight from that assessment model. We have to make sure the requirements are allocated to elements of the system in our system model. We've described what those interfaces are and that they're defined, and that we have the dynamic behavior objectives of those elements defined. And finally, consistency and bidirectional traceability are established between them. So those are the things that we're
That's
kind of going to cover today. So before we get into the actual demo, just to give a brief understanding that Rational Rhapsody is, it's really given that ability to utilize UML and SysML modeling language to be able to model what our systems are, gives us the ability to visualize our requirements, to understand how our system integration is going to work, be able to really reduce the risk and manage the complexity of the systems that we're creating.
And just to check in here, as far as I know, most automotive companies have a pretty robust model-based systems engineering practice already. And so this ought to be a way for them to take what it is, that skill set, and apply it in this tool, and then associate that with requirements, right?
Yeah, that's correct. I mean, we look at most suppliers and everyone in automotive, primarily most of their model-based systems engineering or software engineering is done in Simulink. But the difference between Simulink and Rhapsody is the fact that Rhapsody has the ability to really define the dynamic behavior of your system, whereas Simulink it really focuses on other areas.
Okay.
And so if we look at Rhapsody in itself, it's really what we're going to focus on today is around the requirements visualization.
Okay.
But Rhapsody also has many other areas where you could utilize it for, from model execution to doing simulations of your systems, doing model-driven testing, and some other collaboration capabilities.
And there's some integrations to Simulink, I believe, too, right?
There is, yes. Rhapsody and Simulink are meant to work together. We have lots of organizations that are utilizing them to do co-simulation between Rhapsody and Simulink. So there's lots of different use cases around it. Rhapsody is not a replacement of Simulink.
Right. They work together. That's what I thought.
Yeah.
All right.
Yep. So if we look at, we're able to manage these requirements, validate them, understand those requirements can actually be allocated to those requirements and defined, and we're going to see some of that today. Part of this is translating those system requirements that we have, or any type of requirements, into a system design so we can analyze the impact of changes, whether it's from a requirement standpoint or whether it's from a design standpoint. And we can see that full accountability and understanding based on whatever direction that we're tracing back and forth. As we said, it's establishing that bidirectional traceability between them.
That's pretty cool there, that graphic here where you've got the requirement right there in front of you and then the model right next to it. That's
exactly.
I like that.
So let me switch over to my demo.
All right.
So we're going to start off, and what we're looking at, just a refresher, is this is Doris Next Generation. This is a requirements management module inside of our continuous engineering platform. And what we're looking at is just a subsystem requirement specification. We have the ability in Doris Next Generation to, manage atomic requirements. We also have the ability to filter on those type of requirements to see different views of those requirements.
Wait a minute, atomic requirements?
Yes.
I like that. I've never heard of a requirement called an atomic one. Everyone else may know this, but 10 seconds, what's an atomic requirement?
It's a single granular requirement, right? So instead of having and being able to manage it from a single level, right?
I see.
And so instead of combining requirements, some organizations will manage their requirement specifications in a document, right? You can't manage an individual requirement that way because that document contains maybe 50, hundreds, thousands of requirements.
Yeah.
Right? And if you have to make a change to one of those requirements, now you're versioning that entire document. There's a whole new revision of that document. In Doris Next Generation, we get to take that granular level and go down to what we call an atomic requirement, which we're going to say is one single artifact that we can manage and have its own versioning of.
Thanks, I appreciate
that. The history of it.
Okay, got it.
And each one of those requirements themselves has a unique identifier, and we can filter on specific views because inside of a specification, not everything is actually a requirement. Some things are information. So if we wanted to, we can, use a filter to say, here are all out of everything that's in the specification. Here are all the requirements. All right. So now I've filtered down. You can see now I've filtered out 2 of those artifacts. I'm showing 17 artifacts in this specification are system functional requirements.
Got it.
And the other thing that you can now see is I looked at these requirements. Here's on the view, we can see that we've actually showing that bidirectional traceability to our architecture. We can look at one of these requirements is actually related to and allocated to a state chart that describes the behavior of that system requirement. And
Wow,
this is
that's
a
cool.
navigatable, navigatable diagram where we can see this is what this system is actually doing.
And that actually lives somewhere else, but it's linked.
Exactly.
Okay.
That's
And that one
now
had a
different
check mark
application.
next to it. So it
Yeah.
must be, it's proven that it's like valid or something,
Yeah, it's
right?
a valid link, right? Yeah. And if
All right.
somebody, if I were to make a change to this requirement,
That's going to put a question mark, I bet, right?
they're
There you
going to put a
go.
question mark, right? So that's now going to be noted as a suspect. Now, if I
Just like,
actually go, yeah, so if I go over into the modeling aspect, if I'm the system designer, the systems engineer, and I'm looking at that model, and I go to look at that requirement, I will now see that requirement come up as a suspect. And let's see, I forgot exactly which requirement that was, 3000, right? And now I see it. Now it's marked as suspect.
okay. And then that list there are all the suspect ones in the
Yeah, these are,
project currently.
so so what we've done is we've actually created a link to this model to a view of requirements in DOORS Next Generation. So as you see, I've
Oh,
added
so
a collection
we're
to the,
looking at it the other way around now. So now you're
exactly.
saying,
Now I'm looking in the Rhapsody model, and now I'm looking into, I've added, say, I'm going to allocate requirements from this specific specification into this model. So I'm able to add that collection in and say, here's my view of my requirements. Here are all of those 17 requirements and those functional requirements. Here
that
are the
link
ones
to
that are
this
linked
model? Now, wait a
that
minute.
link to
So
this
all of
model.
these link to this particular model. So all
They
of
can be.
these,
So
they,
as you can
okay.
see, the ones with the link icon down here are actually linked. 2 of them are
I
suspect, one's valid. The rest have no links yet. So we still need to allocate these to the model.
Oh, because so that's what you showed us in your slides, is that all requirements need to be allocated or linked to some sort of model um, in order to meet the criteria
Exactly.
of
ASPICE.
ASPICE.
Yes, that's
Ah,
exactly.
all right.
So here we're looking at Rhapsody, and this is just a simple model that's describing our automated cruise control system. You can see that this system is actually made of 3 separate features. We have a vehicle detection system, an adaptive cruise control module, and a vehicle display module. Right? And each one of those modules in itself, we can go into them, and we can see for the adaptive cruise control that here is the sequence diagram um, that describes the behavior of
Right.
what this feature is going to do. So we can see, well, when we turn from ignition off onto ignition on, all right, the ACC comes into standby mode. Right, we
Right.
have some inputs and outputs that we can say are going to make changes to how we go from standby to active based on
Right.
specific triggers, right? So it's describing the dynamic behavior of that model. And
Right.
as we can see, um, you know, we can look at relating, say, I want to relate this model, that requirement to this model.
The tail lamp activation. Is that what
You
you
know?
And then that will create a link.
Yep, and it's asking you what type of link are you going to select. And so I'm going to say this is going to be a satisfies. And now I have established that link to that block. Right?
And it's
And
marked automatically to start
marked
with
automatically.
with a question mark.
Yep. And
I
so if I
see.
believe this is valid, I'm going to go through and say, you know what? Now that I'm going to mark that one as valid. And I can go and say, I'm going to change this link to valid. There we go. So now that
Nice.
one's marked as valid. Now, the one thing, as you're describing this, you might want to, I can actually remove this from the view, but it doesn't mean that that requirement's gone. As soon as I drag that requirement back onto the field, it's automatically going to establish it.
Right, and you can see it's linked in the other view. So,
Yeah.
well, that's super cool.
And we can also look at it from a table perspective. So managing the, a table format, and seeing what's valid, and these type of views can be configured. Right? So we can see, looking at the requirements that are established for this model, right? We can see what's been satisfied, what the link type is, what the status is of it, and we can see that here's a quick way to analyze, do a gap analysis. There's quite a bit of things that we need to allocate to our requirements.
So I was just going to ask, so does the ASPICE specification, does it require that every one of these requirements be assigned to a model? Is that part of the requirement, or is it just that for those that there's some sort of traceability between them?
Exactly.
So for the ones that have it,
yeah.
there needs to be a link, and you need to be able to validate or invalidate that traceability.
Exactly. And so you need to understand,
but that they satisfy each other, right?
That they satisfy each other, and you also need to. Part of it is ensuring that consistency. So knowing that if a change happens, that there is some notification that goes out.
Sure.
Right. And so somebody knows to make a decision. Okay, I'm going to make a change to this, and that gives you that ability. If you're the systems engineer looking at the model in itself, right, and you say, you know what, I want to make a change to this, I can actually go back and look and see what else is being related. So I can see what else needs to be changed. Right. I can look back at the requirements and say, okay, well, what else is there? What other things downstream do I need to be able to take into consideration before I make a change?
All right. Well, that's good stuff, Amit. That really gives us a feel for how these tools help satisfy ASPICE's both the bidirectional traceability piece, as well as more specifically how requirements are linked to models and how you can communicate whether or not they have been satisfied, or even for analysis, if you change something, how many requirements are going to be affected, or vice versa, if you change a requirement, how many models might need to be updated, and things like that. Is there anything else we need to cover?
No, I think that is about it.
All right.
I'm looking forward to our next topic.
Which is, good segue, yes, we're going to talk about ASPICE and how it's used for software and system qualification testing, and the tools from IBM that support it.
That's correct.
Can you give us a little? There's a quality manager, I believe.
Yep, Rational Quality Manager is going to cover the whole right side of the V. So if you look at the process models again, right, whether you're at system requirements or architecture, or software requirements of software architecture, every step of that needs to be validated by a test case of some type of test specification at each level, whether it's unit testing, integration testing, system testing.
And I assume that they need to pass, and that there's traceabilities. Again, going back to bidirectional traceability, and if there's one doesn't pass, then the requirement that it's associated with may become suspect, or if there changes are made, all of that kind of stuff. Yeah.
Yeah, exactly.
Awesome. Well, we look forward to that. Thanks everybody for watching. Check out the links below for more information to other podcasts, to the prior podcasts here, to other topics like Agile and the Scaled Agile framework. And we look forward to seeing you next time. Thanks for watching.